I am Rudraishwarya Banerjee from Antenna and Microwave Laboratory of San Diego State University, and my presentation topic is New All-Metal Heat-Sink Dual Linear Polarized Phased Array Antenna for X-band applications. Here we propose a 4x2 dual linear polarized phased array antenna comprised of all metallic radiators. The antenna can work both as the radiating aperture and heat sink for dissipating heat from the beamforming board. Anoki wave RFICs are employed for the beamforming network, and the antenna aperture will be 3D metal printed. The antenna aperture will be integrated with the beamforming network, and the antenna will be tested for its impedance matching and radiation pattern in the Antenna and Microwave Lab of San Diego State University. Here we can see the single dual linear polarized antenna and simulated results. We can see that the antenna height is nearly half wavelength, and the antenna footprint is also half wavelength by half wavelength. The antenna covers 8.5 to 11.5 GHz, and the gain for both polarization is nearly 6 dBi at the center frequency. The isolation between two ports is quite good. Here the 4x2 phased array antenna and the simulated results are shown. We have employed a mirror feed technique to reduce the cross-pole in the 4x2 array. Here the bandwidth is 8.5 to 11.5 GHz, and the peak gain is 11.5 dBi for both planes for both poles, and the peak gain to side lobe separation is nearly 12 dB, and co-cross separation is 33 dB, which is quite good. Here the scan performance and the heat sink analysis of the antenna are shown. We can see that the gain drops to 12.5 dBi from 12.86 dBi as beam scans from 0 to 50 degree. And we can see that the temperature range of the antenna aperture is 22 to 23 degrees centigrade. We have employed ANSYS iSpec for heat sink analysis, and we know as we have employed RFICs, and RFICs usually generate huge amount of heat. So as we plot the temperature of the antenna, and the temperature of the antenna aperture is only 22 to 23 degrees centigrade, this indicates that the antenna is working as a very good heat sink. So in conclusion, all metal dual linear polarized radiating element based phased array antenna is analyzed and designed, which can work as heat sink also. And the simulated phased array antenna is scanning till 50 degree, and the temperature of the aperture is only 22 degrees centigrade, which indicates that it is a good heat sink. So our future work is detailed thermal analysis of the 4x2 phased array antenna and fabrication. For fabrication, we can see that the 3D metal printed aperture is already fabricated, which is shown on the slide, and the beamforming board is under fabrication. So when the board will be fabricated, we will integrate the 3D metal printed aperture with the board, and the testing will be done in SDSU's far field anechoic chamber. Thank you.